Hi boys and girls, welcome to your second to last math video of the year. Today we are doing lesson 11.10. Tomorrow the last lesson will cover our chapter review and test prep pages. So grab your Go Math book if you haven't already and open up to page 681. That is where our lesson begins. So today we are going to be looking at shapes that have the same area, which means they cover the same amount of space, but different perimeters. So the outside measurements are different. So let's get started by unlocking this problem. So, Marcy wants to make a pen, a rectangular pen to hold her rabbits. The area of the pen should be 16 square meters. So it should cover 16 squares. The side lengths need to be whole numbers. That just means we can't use fractions and say, okay, one side is going to be 1.5 meters. We're not getting into that. So whole numbers only. What is the least amount of fencing she needs? Well, don't forget this little purplish box over here. What does the least amount of fencing represent? Well, remember, fencing goes around the outside of a pen, so that means we're talking about the perimeter. So we want to find the smallest perimeter Marcy could make her pen, but still cover 16 square meters. So they give us some grid paper here that we could use. If we were in school, we would have little square tiles that we would actually use to manipulate making a pen. Now remember, we can't have any fancy shapes here. She wants it to be a rectangular pen. So let me get my rectangular drawer out to help us. And I'm just going to start by drawing a rectangle and covering 16 square units. So I could just make one very, very long rectangular pen. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That should do it. So I don't know that this is going to be the type of cage that she wants to make for her bunnies because they're not going to have a lot of room to go. It can really just go back and forth. But anyways, it covers 16 square meters. Let's do another one. Let's instead this time make it 2 rows, and I can do 8 on the top and 8 on the bottom. Okay, so that should work here. That gives a little bit more room inside. It's still the same area as the first rectangle, but notice it's just kind of squished in more, so it's increasing the all-around space, even though it's still covering the same area. It's just not as stretched out. And then let's instead, I can't do 3 rows because 16 divided by 3 isn't an even number. So I can do 4 rows. 16 divided by 4 is 4, so I can do 4 rows of 4. Okay, so I could do a rectangle like that. So it looks to be even smaller around the outside, but still giving 16 square units on the inside. But let's go through the math part and make sure that these would work. And remember, we need to find which one has the smallest perimeter, the distance around. So when I made this first rectangle, it covered 16 units across the top and then 16 units across the bottom, and each side was 1 unit. So for the area, we would do 1 times 16, which we know any number times 1 is itself. And for the perimeter, I would need to do a little bit of math. Let's go over to the side here. 16 plus 16, and then I know 1 plus 1 is 2. So we need to get the outer perimeter. I think this is going to be a pretty big one. 6 plus 6 is 12, plus 2 more is 14. Regroup. 1, 2, 3. Okay, so for that first rabbit pen, this would have a perimeter of 34 meters. So 34 seems like a big number. All right, let's go to the second rectangle that I drew. It had measurements of 2 meters on each side and 8 meters across the top and bottom. So this would be 2 times 8, which is 16. So we did a good job there with the area. And then the perimeter would be the outer part of the pen. So I can just add that in my head. I know 8 plus 2 is 10. 8 plus 2 is another 10. 10 plus 10 is 20. So that is much better than the first rectangle. The perimeter is down to 20 meters. Let's see if the third rectangle is even smaller around the outside. So we did 4 meters all the way around. So area, I figured that out by multiplying 4 times 4, which is 16. So the area of all those rectangles is the same, even though they don't look the same, but they are still covering the same amount of space. The perimeter would be adding 4 plus 4 plus 4 plus 4, which is the same as 4 times 4 again, and that is 16 meters. So I can see that that rectangle gives me the smallest perimeter while still covering the same area, which is good because it's going to kind of condense all of the area into one bunch, one group, and it's going to require the least amount of material to go around the outside. So when she's, fencing in her rabbit pen, she's not going to need as much material for rectangle 3 versus the first one, which she would need 34 meters. All right, so to use the least amount of fencing, Marcy should make a rectangular pen with side lengths of 4 meters and 4 meters. So 16 meters is the least amount of fencing that Marcy needs. Okay? Let's go over to the next page and try this a little bit more, just practicing drawing shapes that have the same area but different perimeters. So they want us to draw 3 rectangles that have an area of 18 square units on the grid. Find the perimeter of each and shade in the rectangle that has the greatest perimeter this time. Looking for the greatest. So if I want 18 square units, I can do that first rectangle where I just cover 18 squares in one big long row. So that's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, I could cut that in half and I could do a rectangle that has 2 rows of 9. Because I know 9 plus 9 is 18. 9, 1, 2, 3, 4, 5, 6, 7. I think that's 9. These squares are so small, it's hard to see. And then I could I do 3 rows? 3 times 6 is 18, so sure, I can make a rectangle that is 3 rows and has 6 in each. So you can see how multiplication is still being used here. That's why it's very important to know our facts. And we're going to be adding when we do the perimeter. All right, so let's find the perimeter. We know that they all have an area of 18. All right, the first one's going to have a very big perimeter, I think, because look how long 2 of those sides are. I went 18 meters, I guess units. We don't know if they're meters, but anyways, 18 across the top and 18 on the bottom. The sides are short, but because the sides are only 1 unit, it makes the top and bottom very, very long. So 18 plus 18, and then 1 plus 1 I know is 2. So let's just add that up for the perimeter, that first rectangle. 8 and 2 make 10, plus 8 more is 18. Regroup, 1, 2, 3. All right, so that first rectangle here has a perimeter of 38 units. That's quite a lot. Let's go to that second one. This one, I added an extra unit on each of the side lengths, but we were able to make the top and bottom smaller by cutting them in half, 9 and 9. So 9 plus 9 is 18. 2 plus 2 is 4. The outer perimeter of my second rectangle would be 22. All right, so that's certainly smaller than the first one. Let's go over to our third rectangle. We did 3 rows of 6. So I have 6 and 6, and then my sides measure 3 units. 6 plus 3 is 9, and 6 plus 3 again is 9, and 9 plus 9 is 18. So the perimeter of that third rectangle proved to be the smallest. But remember, we're looking for the rectangle that has the greatest perimeter. So the one with the greatest perimeter is the very first one we did. So they wanted us to shade it in. I'm just going to highlight it here. So I'm noticing that the long shapes, the very long rectangles, have a very large perimeter. And then the shapes that have shorter tops and bottoms have a shorter perimeter. So let's see if that pattern continues as we explore same area, different perimeters. All right, Sharon showed the area of the rectangle at the right is blank square units. The perimeter is blank. All right, so we need to do some solving here. What is the area? Well, I see 3 rows of 3, so 3 times 3 is 9. So there's 9 square units. And if there's 3 on all 4 sides, 3 times 4 is 12. So the perimeter would be 12. Now for number 2, we need to draw a rectangle that has the same area, which means 9, but it has a different perimeter. So instead of making a square like they provided, let's do one very long, skinny rectangle that has 9 units. So 1, 2, 3, 4, 5, 6, 7, 8, one more makes 9. So the area here is still 9 square units, but what is the perimeter now? Well, since I went 9 units across the top, 9 across the bottom, and 1 on each side, 1 plus 9 is 10, 1 plus 9 is 10, and 10 plus 10, you got it, Isis, 20. All right, which rectangle has the greater perimeter? So the first rectangle or the second rectangle? Well, clearly 20 is much larger than 12. So rectangle 2 has the greatest perimeter. All right. If you were given a rectangle with a certain area, how would you draw it so that it had the greatest perimeter? So that's exactly what I was just saying a few moments ago. If you want the greatest perimeter, you need to have the top and bottom be the greatest measurements, which means you want to have a very long, skinny rectangle, and you only want to have 1 unit on 2 of the sides, because that makes it a very long and skinny rectangle. So we could say I would make a long, skinny rectangle with 1 unit on 2 sides. And then the top and bottom, or the other 2 sides, could be, whatever length. But if you do 2 sides that have just 1 unit, it's going to be a very long, skinny rectangle. And that means it's stretching out the perimeter, because it's taking the area, instead of bunching it together so you could just quickly cover the outside, you're taking the area and you're stretching it side by side, and you're taking up a greater distance around. Hopefully that makes sense, that you're seeing these shapes. Sometimes it's confusing when I say it out loud. All right, over to the next page, we are finding the perimeter and area, and this time looking for the rectangle that has the greatest perimeter around. So rectangle A has an area of, I see, 4 units, square units, since we're talking about area. Okay, I hate typing this all out or writing this all out, but got to put our label on there. Okay. And then the perimeter, it's 2 units all around. So 2 times 4 is 8. So 8 units would be our perimeter for the first one. And then on rectangle B, the area is 4 square units. And I'm not going to write the label. We know it's the same as above. And then, that's supposed to be an arrow, by the way. And then the perimeter, it's 4 across the top, so 4 on the bottom. 4 plus 4 is 8. And then 1 on each side would make it 10. And again, same label there. So which rectangle has the greatest perimeter, greatest distance around? Well, 10 is greater than 8, so that would be rectangle B. And again, it follows that pattern. It has a measurement of 1 unit on each side, and it's stretched out across the top and bottom. Okay, on your own, find the perimeter in the area, tell which rectangle has the greater perimeter. So same thing we were just doing. You could probably look at the pictures and at this point, tell me which one is going to have the greatest perimeter without solving anything, but we still have to solve it and figure out the math. But just to guess right now, I'm going to tell you that I believe rectangle A is going to have a greater perimeter because it is longer than rectangle B. Now, we're going to do the math to find out if that's true, but that is what I am predicting. So rectangle A has 1, 2, 3, 4, 5, 6, 7, 8 units, okay, across the top and bottom, and 3 units on each side. So for the area, remember we would do length times width. So 3 times 8 is 24. Don't worry about the units. I'm not going to be a stickler on that right now. The perimeter, we would add 8 plus 8, which is 16. 3 more is 19. And then 3 more on top of that would be 22. So the perimeter would be 22 units. And then for rectangle B, the side lengths are 4 units each. Top and bottom are 6 units each. So for the area, 6 times 4 is 24. So we see that the areas match up. And then the perimeter would be adding all the sides. So 6 plus 4 is 10. 6 plus 4 is another 10. And we know 10 plus 10 is 20. So we can see that the perimeters are different from 22 to 20. So which one has a greater perimeter? You betcha, I was right. Shape A, because it's more stretched out than rectangle B. All right, let's go over to number 8, finding the perimeter and area of these 2 rectangles. For the greatest perimeter, I'm going to go ahead and tell you it's B. Simply looking at those rectangles, I know this because rectangle B is much skinnier and longer, or in this case, taller than rectangle A. So that tells me it's going to cover a greater distance around it. So let's do the math just to prove it. Rectangle A measures 3 units on each side, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units across the top and bottom. So for the area, we would do length times width. 10 times 3 is 30. And for the perimeter, we would add 10 plus 10 is 20. 3 plus 3 is 6. So all the way around, we get 26. Okay, so perimeter of 26. Now when we go to letter B, you can see that there are 2 units across the top and the bottom. And I'm guessing 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 down the side. So 15 times 2 is 30, so has the same area as letter A. And then the perimeter, 15 plus 15 is 30. 2 plus 2 is 4. And that together would make 34. Look at that perimeter. From 26 to 34, definitely letter B is an increase. The greatest. All right, number 9, sense or nonsense? Okay, so Dora says that of all the possible rectangles with the same area, the rectangle with the largest perimeter will have two side lengths that are 1 unit. Does her statement make sense? We talked about this earlier. Yes, it does make sense because if two sides are only 1 unit, it means all of the other sides are going to be much longer. They're going to be as large as possible. So we had said that when you want to make a shape, a rectangle that has the greatest perimeter possible, you want two sides to just be 1 unit, and you want to stretch that rectangle out. So that means the top and the bottom measurements are going to be as large as they can. So we'll say yes, because then the other two sides will be as large as possible. And that's just going to depend on what the area should be. So if the area needs to be, let's say, 10 square feet, then the top and bottom are going to be 10, and then you're going to have 1 unit on each side. And so that's going to give you the greatest perimeter all around. All right, over to our problem solving on the next page here. We have another unlock the problem, a real world problem to look at here. Roberto has 12 tiles. Each tile is 1 square inch. He will arrange them into a rectangle and glue 1-inch stones around the edge. How can Roberto arrange the tiles so that he uses the least number of stones? So it kind of sounds odd. I don't understand what he's doing here. All right, but anyways, he's got rectangular tiles, and then he's putting some round stones around the tiles. He wants to use the least number of stones. So that means we're looking for the smallest perimeter to go around whatever it is he's making. So how will you use what you know about area and perimeter to help you solve the problem? Well, if he wants to use the least number of stones, that means he's going to have to kind of squish the area of whatever he is making together so that the space around, the distance around, is the smallest. And he has 12 tiles, so we can find, we can experiment a little bit. We can practice drawing some rectangles that have an area of 12 units, square inches, and find the one that makes the least perimeter. Okay, so we could say I will make rectangles with an area of 12, and they told us square inches. Okay, with an area of 12 square inches, and compare the perimeters. Okay, we'll compare the perimeters here and see which one yields the shortest perimeter. So we need to draw some possible rectangles to solve the problem and label them A, B, and C. So they want us to draw 3 rectangles. So first one here, I'm going to just make a very long, skinny rectangle, right? It's going to cover 12 units. So 2, 4, 6, 8, 10, 12. I'll tell you what, these squares on this grid are so small. Hopefully they're a little bigger in your book. My second one, I can, instead of doing 1 unit on the sides, I could do 2 units, and then this time do 6 in each row. 1, 2, 3, 4, 5, 6. Okay. And then, let's see, I could even do one that has 3 units down the side, because 12 divided by 3 is 4. So 4, 8, 12. There we go. Okay, so these are my 3 rectangles. I've got rectangle A, B, and C. And we need to figure out which one gives us the smallest perimeter. So out of A, B, and C, without even finding out any of the math, which one has the smallest perimeter? A, B, or C? Yeah, C, because if you've been paying attention in this video, we've said that the largest perimeter is going to have the largest top and bottom side, so it wouldn't be A. B is kind of right in the middle. C has the shortest sides on the top and bottom, and so it has the shortest perimeter. Okay, so letter C. Number 11, think smart. Draw two different rectangles with an area of 20 square units. What is the perimeter of each rectangle? Okay, so we only have to draw two. I don't know that they gave me enough room to just make one skinny rectangle with 20 square units. So let's do 2 rows of 10. 2, 4, 6. That's not gonna work. I needed to start over at the edge. You hear Coda? He's trying to bark at a bird that's outside. Oh goodness, what the heck's going on? Coda, zip it. Let me start this again. Okay. I really don't like teaching math like this. Okay. So that should cover 20 square units. And just to go through the perimeter, it would have 10 across the top, so 10 on the bottom, that's 20. 2 on each side, that makes 2 plus 2, 4. So the perimeter would be 24 units. Okay, that's one option. My second rectangle has to be 20 square units. So I could do, trying to think what divides into 20. I could do 20 divided by 4. What is going on here? Can't do that. So I could do 4 rows of 5. 1, 2, 3, 4, 5. Okay, if I do 4 rows of 5, 4 times 5 is 20, so that works. So then there would be 4, 5, 4, 5. Wait. Oh my gosh, I'm losing it, guys. Okay. Thanks for bearing with me. 5 would go up here on the top and 4 on the other side. Anyways, what would our perimeter be? 5 plus 5 is 10. 4 plus 4 is 8. Totaling out 18. So just those two rectangles of 20 square units for the area have a perimeter of 24 and then a perimeter of 18. All right, our favorite time of the lesson here, the practice and homework. I like to call it my home stretch. Let's get it done. Number 1 has been partially done for us. We need to finish it off by finding the area and perimeter of rectangle B and finding which rectangle has the greatest perimeter. I already know that it's going to be rectangle A because of what we've learned in this lesson. Rectangle A has 2 sides that measure 1 unit, and it's a very long, skinny rectangle. All right, but for B, it has 2 units on the sides, 4 on the top and bottom, so the area is going to be 8 square units, and the perimeter would be 4 across the top and bottom, so 4 plus 4 is 8, and 2 plus 2 is 4, and 8 plus 4 is 12. Yes, I'm going to make you slap on your labels there. Square units for the area and units for the perimeter. No whining. Okay, moving on. Number 2, same thing as number 1. Rectangle A has 3 units on the side, 4 units top and bottom. Area, 3 times 4 is 12. And then the perimeter, we're adding up all the sides. 3 plus 4 is 7, plus another 7 is 14. So perimeter of 14. For rectangle B, it has a measurement of 2 units on the sides and 6 on the top and bottom. So 6 times 2 is 12 for the area. Perimeter, distance around, we would do 6 plus 6 is 12. Plus 2 is 14, plus 2 more is 16. So it has a perimeter of 16. Let me get my labels on here. Make sure you are labeling your answers too. Good habit, good practice. Okay, so you square units for the area, units for the perimeter, and which rectangle has the greatest perimeter? Well, I could have already told you my answer before I solved anything. Rectangle B, because it's a longer, skinnier rectangle than A. Problem solving. Use these tile designs. Beth's tile designs, okay, A and B. Compare the designs of areas of design A and design B. So the area of A would be 2 units on the side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, across the top and bottom. So that area would equal 20. And then tile design B has 4 on the sides and 5 across the top and bottom. So that area would equal 20. So how do we compare them? Well, we would say they are the same. Same areas. The areas are the same at 20 square units. Okay? Same area, but they're going to have different perimeters. So now, number 4, we're comparing the perimeter. Should have known that was coming. All right, rectangle A, if there's 10 across the bottom and top, that makes 20, and then 2 on each side is 4. So that gives us a perimeter of 24. Rectangle B, 5 on the top and bottom is 10, 4 on each side is 8. 10 and 8 make 18. So which one has a greater perimeter? Rectangle A, or we could say tile design A. And we could have guessed that without solving any work because it's a much longer, skinnier rectangle, as we have learned. All right, last page, lesson check number 1. Here we go. Jake drew 2 rectangles. Which rectangle has the greater perimeter? Don't solve anything. Which one is it? Is it A? Nope, it is B, because it is a longer, skinnier rectangle. And when we have 2 sides that measure just 1 unit, we know the other 2 are going to be as large as possible, and the overall distance around will be greater. Okay? Number 2, Alyssa drew these 2 rectangles. Which rectangle has the greater perimeter? Again, we don't need to find out any math. Look at the picture and what we've learned in this lesson. It's going to be rectangle A because it's a much longer, skinnier rectangle. So it's going to have a greater distance around it. Okay, spiral review. Marcia was asked to find the value of 8 minus 3 times 2. She wrote a wrong answer. What is the correct answer? I'm sorry, Marcia. Remember, when we are solving a problem and has different operations, we have to multiply and divide first, and then we do the adding and subtracting after. So we're going to do 3 times 2 first, which is 6, and then bring down the 8 minus 6, and that equals 2. So her answer should have been 2, but maybe she did 8 minus 6 first and got 2, and then did 2 times 2 and got 4. That would be my guess. She didn't know the order of operations to follow. Number 4, what fraction names the point on this number line? Well, this number line is divided into 4 total parts, so that is my denominator, the total number of parts, and it is on the first, second, third point, so that means 3/4. Number 5, Kyle drew 3 line segments with these lengths, 2/4 inch, 2/3 of an inch, and 2/6 of an inch. List the fractions in order from least to greatest. Well, they all have the same numerator, so I can go ahead and write that part out. let's think of what we learned with denominators. And this is where Rikari had a little chant she would tell us all the time. So remember what she would always say: the bigger the denominator, the smaller the pieces. Something like that, right, Rikari? So if we have something that is 2/4 compared to 2/3, 3 is a smaller number, but it's going to be a larger amount. And then 6 is a big number, but it's going to be a small amount. So 2/6 would come first. 2/4 would be in the middle. 2/3 would be the greatest. And wrapping it up for today, on Monday, 3/8 inch of snow fell. Oh my gosh, why are they talking about snow? I pray we're done seeing snow. Okay, so 3/8 inch of snow fell. On Tuesday, 5/8 inch of snow fell. Write a statement that correctly compares the snow amounts. So 3/8 compared to 5/8, what are we going to say? This time the denominators are the same. It's our numerators that are different. And 3 is less than 5. So we would say less than. And I certainly hope it does not snow at all ever again until the winter. All right, guys, so that ends our math lesson for today. Tune in for tomorrow's video where we do the end of chapter review pages, and that's a wrap. So hang in there for one more lesson. Talk to you guys later.